Math. Today we are going to look at rational exponents and their properties, and we're going to basically concentrate on three different properties. The first one that we're going to look at is the product of powers property. Well, we know the product of powers. If you have two like bases, in this case we have 7 to the 1/2 times 7 to the 3/2. We just add the exponents when you have like bases. So it's going to be 7 to the 1/2 plus 3/2, which ends up being 7 to the 4/2, which is 7 to the 2nd, which is just 49. So we just take our rational exponents and we add them. Okay, the next one we're going to look at is the power of a power property. So if you have a base, in this case it's 6 raised to the 3/4 power, we have all that raised to the 4th. We multiply the rational exponent, which is 3/4 times 4, and that becomes 6 cubed, 6 to the 3rd, which is just 216. So that's how we handle the power to power, power of a power, and then a power of a power, or power of a product property is the last one. Well, we have a product, which just means we have two terms being multiplied. So 8 times 125 to the 1/3. Well, we can take this 1/3 and we can basically distribute it in to each term. So we have 8 to the 1/3 times 125 to the 1/3, and then evaluate each one of these separately. So we know that 8 to the 1/3, that just means the cube root of 8, which is 2. And 125 to the 1/3, that just means the cube root of 125, which is 5. And then multiply those together to get 100. Okay, so those are the three properties we're going to concentrate on today. So let's try a few of these. Let's start with the product of powers. So on this one, we'll just start with a very basic. This doesn't even have fractional exponents. We just start reviewing the property. So when you multiply like bases, we add exponents. That's just going to give us 4 to the 6th power. Okay, so let's try the second one over here. 8 to the 1/2 times 8 to the 1/6. Well, we need to add those exponents. So let's get a common denominator. And in this case, our denominator would be 6. So that's going to be 8 to the 3/6 times 8 to the 1/6. And that's going to give us 8 to the 4/6. Now that reduces to the 2/3. So that will give us 8 to the 2/3 power. Now we can evaluate that without using a calculator, because we know that the denominator is telling us it's the cube root. So we know the cube root of 8 is 2, and then 2 squared. Once we use the denominator, we've got to square that, and that just simplifies to 4. So there's our answer. That simplifies all the way down to 4. So let's try this next one. 2 to the 2/3 times 2 to the 1/4. What's our common denominator is 12. So that means we need to multiply the first one by 4 over 4. So times 4 times 4. And that's going to give us 8/12 times 2 to the 3/12. Because I would multiply 4 by 3 over 3 to get 3/12. And that will combine to 2 to the 11/12 once I add my exponents. Now, 2 doesn't have a 12th root, so we're finished with that one. There's no simplifying that can be done. Okay, let's look at the next one. We have 9 to the 3/2 times 9 to the 1/4. Let's get a common denominator of 4. So that's going to give us 6/4 times 9 to the 1/4. And that's going to give us 9 to the 7/4 power. And we can't find a 4th root of 9. So we are finished with 9 to the 7/4. Okay, what if we're given the same type of problem, but it's in radical form? What we can actually do is rewrite it. So we have rational exponents. So we're going to write that to the 1/3. So 16, the cube root of 16 can be written as 16 to the 1/3 times 16 to the 1/5. Now To get a common denominator, we would get 15. So that would be 16 to the 5/15 times 16 to the 3/15, and that simplifies to 16 to the 8/15. Then there's not a 15th root of 16, so there is our answer. And that's how we handle just the power rule. Okay, now let's look at the power of powers rule. So now we have 4 to the 1/3 times 4 to the 1/4 all to the 6. We can actually take this exponent and distribute it in and simplify this. So we're going to get 4 to the 1/3 times 6/1 times 4 to the 1/4 times 6/1. So we're just distributing that 6 into each exponent. It's supposed to be a 6 right here. Okay, so that gives us 4 to that would give us 6/3, which is just 2 times 4 to the 6/4, which is 3/2. And now we can simplify these very easily. Okay, we can take, let's start with the second one, because this one we're taking the square root of 4, which is 2, and then we're cubing it, times 4 squared, and we know 4 squared is 16, and 2 cubed is 8. So 8 times 16, let's see, that's 48. Carry the 4, and that's 128. So that would be our final answer. I'll simplify it all the way to 128. Okay, let's try the second one. Okay, we've got these written in radical form, so let's rewrite them as rationals. So that's going to be 4 to the 1/5 times 4 to the 1/2. Now let's distribute that 10 in. Okay, so we've got this 10. Let's distribute it to each of these exponents, and that would be 4 to the, well, 10/5 would be squared 2, and then 4 to the, well, that would give us 10/2, which is 5. So we've got 4 to the 7th power, and that would be the answer, or you could actually multiply that out if you wanted to. Okay, and let's look at this last one. So we've got the 5 to the 3/2 all to the 2/3. So we're raising a rational exponent to another fractional rational exponent. So let's distribute that in. So we have 5 to the 3/4 times 2/3. Well, when we simplify that, the 3's are just going to cancel. We can cross cancel that, and we get 2/4, which is a half. So that's just 5 to the 1/2. And there's our answer. Okay? So that's the power of powers property. That one's pretty basic. Now let's look at the power of a product property. Okay, what we can do with the power of the product, we have a product and we've got all that product raised to a power. Well, we can again distribute this exponent in, so we can take 16 to the 1/3 times 32 to the 1/3, and we can evaluate each one of these. Okay, now this just means the cube root of 16. So let's see if we can evaluate that. Well, we know that 16 is 2 times 2 times 2 times 2, and so that's going to give us 3 2's with a 2 left over. So we have 2 cube root of 2, and 32 is going to be 2 times 2 times 2 times 2 times 1 more 2. So if we take the cube root of that, we'll take a 2 out. So we have times 2 to the cube root of 4. Okay, now we have 2 times 2 on the outside, so we're going to multiply the outside together, and that's going to give us 4. And then we're going to have cube root of, we'll multiply the inside together. 2 times 4 is 8. But wait a minute. What's the cube root of 8? The cube root of 8 is 2. So let's simplify that. 2, 4 times 2, which is 8. So there's our final answer. Okay. The next one, let's try this one. We're going to distribute this in and take each one to the 1/2. So 8 to the 1/2 times 4 to the 1/2. We can simplify, well, 4 to the 1/2 is easy. That's the square root of 4, which is just 2. And this just means the square root of 8. Well, by now, hopefully you guys are comfortable with 2 times 2 times 2, which is, let's see, take a pair out. That becomes 2 square root of 2. Oh, wait a minute. We were doing square roots. Times 2. Well, we have outside and outside, so 2 times 2 is 4. So we have 4 square root 2 as our final answer. Okay, now we're going to start doing some mixed problems. We have a little bit of everything. Here's our first one. We have the 5th root of 16 times the square root of 2. Well, since these are different roots, we can't multiply 16 times 2 and then multiply the roots. Basically, we're saying 16 to the 1/5. What's the 5th root of 16 times 2 to the 1/2? Let's write them as rationals first. Now, we know we need to get like bases. Well, can't we rewrite 16 to be 2 to the 4th? So 2 to the 4th all to the 1/5 times 2 to the 1/2. Now, let's simplify that to 2 to the 4/5 times 2 to the 1/2. We're getting closer. We have like bases. Now we need like denominators. So let's change this so they both have a denominator of 10. So multiply the first one by 2. So that will give us 8/10. And multiply the second one by 5, right? That would give us a 10 in the denominator. And so that gives us 5/10. And now let's add those together. So we have 2 to the 13/10. Now, this one's a little trickier, okay? We have the 10th root of 13, we have the 10th root of 2 to the 13th, which means under the 10th root, we have 13 2's. Well, we know if we have 13 2's, I'm not going to write them all out. If these are the 13, or 10 of them, those 10 are going to come out in another group. This is the 11th, this is the 12th, and that's the 13th. So we're going to take out one group of 2's. So 2 to the 10th root of the 3 2's which are left, which is 2 times 2 times 2, or 8. And that would be our answer. So it's 2 10th root of 8. Ooh, these get a little trickier, don't they? Okay, let's try these. We have the cube root of 16 times the cube root of 4. Now notice this one's a little bit different. They're both cube roots. So guess what? We can multiply the insides together. So we're going to have the cube root of 64. Well, that's pretty easy to work with. We know that that's 4 times 16, which is 4 times 4 times 4, which is just 4. So there's our answer to that one. That one's pretty easy. Okay, now let's try this one. We have the product and exponents. So this one's a little trickier. Okay, so we've got to take this negative 1/4 and multiply it in. So we're going to get 3 to the negative 2/4. Ooh, we have a negative exponent too. We'll have to talk about that. Times 6 to the negative 2/4. Okay, so let's see. We can probably simplify these a little bit. That means we have 3 to the negative 1/2 times 6 to the negative 1/2. Okay, we don't have like bases, but we can simplify these a little bit. So we have basically 1 over the square root of 3 times 1 over the square root of 6. Now, why am I putting them in the denominator? Because we have negatives, which means they move to the denominator. Now we have both as square roots, so we have 1 over the square root of 18. Now we know the square root of 18 simplifies to 2 times 9, which is 3 times 3. So let's simplify that to 1 over 3 root 2. Now we're really close. We're almost done. We've got 1 square root left, but we can't leave it in the denominator, so let's rationalize the denominator by multiplying the top and the bottom by root 2. So you have square root of 2 over 3 times the square root of 4, which is just 2, which is 6. So there is our final answer. Ooh, that was a lot of work, wasn't it? Okay, so let's try this one. We need to simplify these. This one's actually kind of easy. You guys have done these before. I'm going to take this and rewrite it like this as rational exponents. So I have 5 to the 1/5, or 1/4, x to the 6/4, y to the 8/4, and z to the 10/4. Okay, now what I can do is anything that has a value greater than 1, basically we're saying it's coming out of the radical. So I'm going to bring 1x out because 4 goes into 6 once. I'm going to bring a y squared out because 4 goes into 8 twice. And then I'm going to bring a z squared out because 4 goes into 10 twice. But I still have a fourth root of what's left. Well, a 5, let's see, I have an x squared left. All the y's came out, didn't they? That divided evenly. And then z to the second. And that's how you would simplify this one, okay, looking at it as a rational exponent. And then this last one, let's just distribute this one in. But I want you to be careful because when you distribute this in, this gets applied to every single term. So you have 9 to the 3/2. You have x to the 12/2 all over y to the 12/2. Whoops, I put 4, but I'm at 12/2. So let's simplify this. Okay, 9 has a square root. So the square root of 9 is 3. 3 squared is 27. And then you have x to the 12/2, which is 6. And then we're going to have y, which is 12/2, which is also 6. So there's how this one simplifies all the way down. So I think that's about it. If you need some more practice, I've got this website. You can stop and put it in, but you can go to this website and practice if you need some more examples to look at. Hope this video was helpful.